Hello again. We are continuing our discussion of factoring polynomials, and again we're going to be talking about a very special case, and those are polynomials that are of the form ax squared plus bx plus c. So there's a number multiplied by an x squared, there's a number multiplied by x, and then there's a constant at the end. All right, so again, like we did in the last lesson, let's review what it looks like when we multiply binomials together, all right, and see if we can figure out some kind of a pattern. If I do 3x plus 1 times 2x plus 3, and I use FOIL or distributive property or whatever you want to call it, that gives me 6x squared plus 9x plus 2x plus 3. And you'll notice that there are two middle terms, both of which have x, so I can simplify those to be 6x squared plus 11x plus 3. Then, if I multiply 4x plus 1 times 5x plus 4, using the same process, I get 20x squared plus 16x plus 5x plus 4. And again, the two middle terms can simplify to be 21x. So my final answer is 20x squared plus 21x plus 4. Another example, if I have 7x plus 2 times x minus 3, I get 7x squared minus 21x plus 2x minus 6, which simplifies to 7x squared minus 19x minus 6. If I have 3x minus 5 times 4x plus 7, I get 12x squared plus 21x minus 20x minus 35, and that simplifies to be 12x squared plus 1x, or just x, minus 35. And then lastly, if I have 2x minus 9 times 9x minus 2, I get 18x squared minus 4x minus 81x plus 18, and that simplifies to 18x squared minus 85x plus 18. So I'm looking for a pattern with those examples. And so let's work backwards from one of the first ones we did. We had 6x squared plus 11x plus 3, and that came from 3x plus 1 times 2x plus 3. Okay, so looking at the examples again, and you see that that one is the very first one, I want you to notice how the two middle numbers, which I've highlighted in blue, and the outside two numbers, which I've highlighted in red, they multiply to give the same thing. Okay, so 6 times 3 is the same thing as 9 times 2. 20 times 4 is the same thing as 16 times 5, and so on down the list. And what you also need to notice is that those two middle numbers, which are in blue, had to be simplified to give one middle number. All right, so in order to factor these, I need the two numbers that multiply to give the same thing as the outside numbers when they're multiplied, and the two numbers have to add to give that number that is in the middle. All right, so let's think of area like we did with the last lesson. If a rectangle has an area of 2x squared plus 7x plus 3, I would like to know what the length and the width are. What are the two polynomials that are going to multiply to give 2x squared plus 7x plus 3? Well, I've got two of the big squares, those are my x squareds. I've got 7 rectangles, those are x's, and I've got 3 little squares, each one representing 1, so that's a total of 3. All right, and I'm trying to make a rectangle out of these. So what I do is I look for the two numbers that multiply to give whatever 2 times 3 is, whatever the first number times the last number is, and add to give 7, which is the middle number, and those two numbers are 6 and 1. So let's go ahead and make a rectangle. If I organize all of those rectangles and squares to look like this, then that's what I have. And so my length is one of those x's plus 3, and the width is 2 x's plus 1. So that means the factorization is x plus 3 times 2x plus 1. Okay, notice how the two numbers that I was looking for show up in how I group those x's. So the two numbers that multiplied to give 2 times 3 and added to give 7 were 6 and 1. You'll notice how I have in the top right a group of 6 x's, and then in the bottom left of my picture I've got a group of 1x. Okay, so that is not a coincidence. It always works out that way. We're going to go over 3 methods to factor these trinomials, and you can use whichever one you prefer. I will not ask you to do one specific method. You can choose. So we've got 3x squared plus 8x plus 4. So I need two numbers that multiply to give whatever 3 times 4 is and add to give 8. So just like I did with the last ones, I'm going to see which pairs of numbers multiply to give 3 times 4 first, and then I will see which of those pairs add up to 8. Okay, and so that gives me 6 and 2. All right, so what you do is you split the middle term. That 8x now gets split into 6x and 2x. And honestly, you can write them in either order. You'll still get the same answer either way. All right, and so what we do after that, once we've split the middle term, is we now have 4 terms which can be paired up, and I factor each pair separately. If I look at 3x squared plus 6x, they have a common factor of 3x, and when I factor that out, I'm left with x from the first term plus 2 from the second term. Looking at the second pair, the 2x plus 4, they have a common factor of 2, and if I factor that out, I get x from the first term and 2 from the second term. Notice how I've got the same thing in both sets of parentheses. That's not a coincidence. That should happen every time, and if it doesn't, that means you need to check your work and try again, go back a step or two. All right, so what we're going to do is factor out those parentheses from both parts. So if I factor it out from that first set, I'm left with 3x, and if I factor it out from that second set, I'm left with 2. So my factorization is x plus 2 times 3x plus 2. Okay, here's another example. Let's say I have the polynomial 2x squared minus 3x minus 9. So I need 2 numbers that multiply to give whatever 2 times negative 9 is, and they have to add to the middle number, which is negative 3. So after some studying, I realized that the 2 numbers are 3 and negative 6. So I split the middle term. So the negative 3x becomes 3x plus negative 6x. That gives me 4 terms, which I can then pair up and factor. So in the first pair, I can factor out an x, leaving me with 2x plus 3. And in the second pair, I can factor out a negative 3, leaving me with 2x plus 3. Notice again that the stuff in parentheses is exactly the same, and it's supposed to be that way. So what I will do is I will factor out those parentheses from both parts. So the first set of parentheses is 2x plus 3, and I'm left with x from the first part and minus 3 from the second part. So the factorization is 2x plus 3 times x minus 3. All right, here's a second method, which I call the box method. We used something similar when we were multiplying polynomials together, and so now we're kind of doing the opposite. So we'll do that same example that I started with 3x squared plus 8x plus 4, and I'm going to make a box. I'm going to put the very first term in the top left, so the 3x squared goes there. I'm going to put 4 in the bottom right. And then I still need to find those 2 numbers that multiply to give whatever 3 times 4 is and add to give 8. And remember, those 2 numbers were 6 and 2. So I'm going to split up the 8x, just like I did in the first method, but I'm using a box this time. And I'm going to put the 6x in one box and the 2x in the other box. And honestly, again, it doesn't matter which one goes where. You'll get the same answer either way. So we'll write the greatest common factor at the top of each column. The greatest common factor for 3x squared and 2x is just x, and the greatest common factor for 6x and 4 is 2. Then I do the same thing with the rows, find the greatest common factor. So for the first row, it's 3x, and for the second row, it is 2. And if I look at the top of each column and the left side of each row, there's my factorization right there. X plus 2 from the top of the columns, and 3x plus 2 from the left side of each row. All right, let's do another example of this just to be sure. So I have 2x squared minus 3x plus 9. That was the second example that I did for the first method as well. Still going to make a 2 by 2 box. 2x squared goes in the top left, negative 9 goes in the bottom right, but I'm going to have to split up that negative 3. So I need 2 numbers that multiply to give 2 times negative 9, whatever that is, and add to give negative 3. Those 2 numbers, if you remember, were 3 and negative 6. So I put 3x in one of the boxes and negative 6x in the other box, and it doesn't matter which one goes where. So I go ahead and find the greatest common factor of each column. For the first column, it's going to be 2x, and for the second column, the greatest common factor is going to be 3. And I do the same thing for the rows. X for the first row, negative 3 for the second row. And a little note here, if a row or a column begins with a negative number, then the GCF, the greatest common factor that you pull out of those terms, has to be negative as well. So make sure you remember that, otherwise you'll end up with some bad answers. Okay, so my factorization is 2x plus 3 from the top of the columns and x minus 3 from the left of the rows. So there's my factorization there. Okay, the very last method I want to go over with you is called swing and divide. All right, I'll start with the first example that I've done for every other method, and hopefully I'll get the same answer. It's 3x squared plus 8x plus 4. Now what I'm going to do is I'm going to create an entirely new polynomial, and I'm going to factor that in hopes of getting to my answer quicker. So what I do is I multiply a and c, and that's going to be my new c. And my new a will be 1. So basically that 3 and that 4 get multiplied, and that's my new last number, and that means that my first term is just going to be x squared. So what I have is x squared plus 8x plus 12. And now, since I know how to factor things more quickly if they have a leading coefficient of 1, I'm going to factor this by doing what I've always done. I need two numbers that multiply to give that last number, which is 12, and add to give 8. So those numbers are 2 and 6. So my factorization of the polynomial that I created is x plus 2 times x plus 6. But that's not the actual factorization of the one that I was supposed to factor. However, from here, it's a small adjustment to get to the real answer. So in order to adjust this answer to make the real one, I'm going to divide each of the constants that are in parentheses by that 3 that used to be the first number in the polynomial. So I'm going to divide the 2 by 3, and that's going to make 2/3. I'm going to divide the 6 by 3, and that's going to make 6/3. And then the last place I need to put a 3 is right at the very beginning as like a lead coefficient. All right, so that's finished. It just looks a little ugly. I'm going to simplify some things. That's 6 over 3. I know what that is. That's actually 2, so I can simplify that. And then I can go ahead, because I don't like fractions too much right now anyways. What I can do is I can multiply that first set of parentheses by 3, and that will get me 3x plus 2 times x plus 2. Okay, and that's the factorization that I got in both of the other methods, so it's a good thing that I got the same answer this time. Here's one last example. It's the same example that I did with the other methods. It's 2x squared minus 3x minus 9. And so if I multiply the 2 at the beginning by the negative 9 at the end, I get negative 18. So my new polynomial is x squared minus 3x minus 18. And that I can factor more easily. I just need to find two numbers that multiply to give the negative 18 at the end and add to give the negative 3 in the middle. Those two numbers are 3 and negative 6. So my early factorization is x plus 3 times x minus 6. That's not the real one. I need to adjust. And so I look back at the lead coefficient that I started with. That was a 2. So I'm going to divide each of those constants by 2. So 3 becomes 3 over 2, and 6 becomes 6 over 2. And I remember to stick a 2 out in front. And so there's my factorization. It's just a little messy. So I'm going to reduce the 6 over 2. 6 divided by 2, I know that that's 3. And then I've got that 3 halves sitting in the parentheses. I'm going to distribute that 2 to those parentheses to make something that looks nicer. And it's going to be 2x plus 3 times x minus 3. And that's the answer that I got for the other methods as well. So 3 methods for doing this. You can choose your favorite. I won't force you to do one over the other. So just choose the one that works best for you. If you have any questions, please let me know, and I will see you tomorrow.